In our previous video, we had implemented Saga design pattern with choreography. There, every service first update their database and then produce an event to Kafka. If you have not watched that video, I recommend you to watch that first so that you will have a complete understanding of how different system components interact with each other. Now here we have two external systems in our service. One is database and other is Kafka message broker. Now we want to make sure that both the external systems are updated in atomic fashion. We do not want a situation where, for example, if database update succeeds but the write to Kafka fails, because in such cases the system ends up in an inconsistent state. So whenever we have two external systems and we need the update to be atomic, in those cases the dual write problem occurs. Now let's understand how this problem can occur with a very simple example. Consider this is a simple banking system. Here we will only focus on account service for our example. So whenever someone deposit money, then account service will receive a command deposit money. Account service will perform two actions on receiving this command. First, it will update the database with transaction details, and then it will produce a Kafka event so that other services can consume and update accordingly. Now here, what if the database update is successful but sending message to Kafka fails? Due to this, the system could end up in an inconsistent state. This inconsistent state is the result of dual write problem because we are trying to write on two different external systems. Okay, I hope now the problem is clear. Now let's see how we can fix this problem. What if we try to change the sequence of the actions? That means we publish the event first and then try to save the data to database. In this case, we will still have inconsistency and dual write problem. It is just at a different stage because it is possible that we successfully emit the event but fail to save in database. So reordering the operations won't work because we need them to be atomic no matter what order they occur. Either both operations succeed or both operations failed. In between states are unacceptable. Another approach we can think of is using a database transaction to cover both the operations. We could wrap both the database write and Kafka write in a single database transaction. Here we have wrapped both database update and event publish in a single transaction. So first database is updated but not committed, then event is published, and if both are successful, only then the database update is committed. But will this really solve the problem? Unfortunately, no. Let's try to understand why. We will discuss two scenarios. Suppose a failure has occurred after the database update but before publishing the event. In this, the database update which was done earlier will be rolled back. In this case, neither Kafka event nor database will have record of the transaction. So consistency of the data is maintained. Now in another scenario, suppose database update is successful and also the event is published to Kafka. But just before committing the transaction, something failed. In that case, database update will be rolled back, but unfortunately, the event is already emitted and the producer will not have any control on rolling it back. With this, once again, we end up in an inconsistent state where we have an event published, but there is no corresponding database update available. So as we have seen, using these strategies does not solve our problem. If we look closely, both the actions are tightly coupled. We need to find a solution in which first write is performed independently from the second write. After the first write is complete, then the second write should be triggered independently. It can be a separate process that can retry the second part until it succeeds. Now, if the first write fails, the second is never triggered. And once first succeeds, the second will eventually be completed. This is exactly what the transactional outbox pattern is. So instead of performing a dual write directly to both the database and message broker, the application write both the business data and the event data into the same database transaction. Now to implement this pattern, a separate outbox table is created in the same database. The table contains events that needs to be delivered to the message broker. So when the deposit money command is issued, a database transaction will be started. First, the data will be updated in business table and then event related data is added to the outbox table. Both of these database operations are part of a single transaction. They are both either succeeded or rolled back. This ensures that every business table update has a corresponding event in the outbox table. Now a separate process will be running which checks the outbox table for all the unprocessed events. And in case any of these found, those events will be published to the message broker. Now here retry can also be implemented to make sure the event is published. Now once the event is successfully published to the message broker, it can be marked as processed or deleted from the Outbox table itself. Now there are different ways to implement the Outbox processing service. It can be a code implementation which is simple but more time consuming. In this you will have more control over how to process the Outbox table. Another way is you can use a change data capture tool if your database supports it. There you will depend on an external tool and will have less control. The transactional outbox pattern works well for solving the dual write problem, but it is restricted to transactional databases only. If a system is using database that is non-transactional, then it will not work. So here is a question for you. How you will handle the dual write problem for the systems that does not support transactions? Do let me know in the comment section. So that's all about dual write problem and how to solve it. If you find this video useful, do like, share and subscribe, and also press the bell icon so that you won't miss any new update. I'll see you in the next video. Till then, let's keep learning.